So moving on with 2018, we've got a parallelogram and we're asked to find alpha and beta. So this is a fairly simple one. This here is 115 degrees, which means that this across from it, alpha, is also 115 degrees, because the opposite sides of a parallelogram are always equal to each other. So beta then is next. Beta then, so these two together, 115 and beta, must add up together to give 180 degrees. So if two of them have got to add up to give 180 degrees, then beta is going to be 65 degrees. So alpha there, 115 degrees. Beta then is going to be equal to 65 degrees. And if you wanted to put your workings in here, it would be 180 degrees. That's for beta. 180 degrees minus 115 degrees. Okay, next one. Explain why the triangle PQR is congruent. So PQR. This. So let's put in some angles. So this one here is now 65 degrees. And this one here is now 115 degrees. And it's looking at triangle PQR. So P to Q to R. So we're looking at this triangle here. And it wants to know about congruency. So congruency is the side, 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 angle, side, angle, side, angle, and RHS for right angle, hypotenuse, and side. So it's got to be one of these that it probably obeys. There's loads of different ways you can actually go through this in a parallelogram. You know that this side and this side are the same. And you also know that this side and this side are the same. So using that, you can also maybe look at the shared line. So P to R in the blue triangle is the same as P to R in the pink triangle. So there's your first one that you could use. So the way to write this down is PS is equal to QR, and that's a side. You can also do SR, or RS, is equal to P to Q. That's another side. And then you have PR in one triangle is equal to PR in the other triangle. And that's called a shared side. And because you have these three, you can say PQR is congruent, which is 3 equals, to RSP. And say by side, side, side. That's one way you can do it. There's other ways you can do it, angle, side, angle, or side, angle, side. There's a few options for you. Let's move on to the next one. So 2018 question 4. But just before we actually move on, just to remind you, in this here where we put in these reasons, the marking scheme gives full credit for 3 statements, and that's these. They're your 3 statements. And then your 3 reasons. And that's these ones here. And only if you do those do you get a full credit. If you leave that out, you're not going to get full credit. You're going to lose out in marks. So 2018, it gives us a diagram with all different bits and pieces filled in. And let's move on to the first part. Use the theorem of Pythagoras to find RQ. So we're interested in this line here. That's what we've got to find. So let's start with the bottom triangle. So we're dealing with a triangle that looks like this. We've got 6.5. We've got 3.3. And we're asked to find that side there, x. This is a right angle triangle. Now, that there is the hypotenuse. Let's take that account into your calculations. So we've got 6.5 squared. Hypotenuse squared is equal to the other 2 sides squared, and add it together, 3.3 squared. So you end up with x squared is equal to, well, I worked it out there earlier on, it's 31.36. So x then is equal to the square root of that, which is 5.6 meters. So go back in here, That's good practice on your exam papers to write in what? 5.6. Okay, show that alpha is equal to 31 degrees, correct to the nearest degree. So we want to show that that is 31 degrees. So is it? So how do we do that? Well, let's have a look. Well, one of the ways you can do it, if you're working off this triangle, again, do a quick sketch of your triangle. This one here, we don't know. This is alpha. And then we have a couple of other sides. We have 3.3, we have 6.5, and we have x. So what we'll do is we will label each of the sides working off the angle alpha. This is the opposite, and this is the hypotenuse, and this is the adjacent. Now, we've already figured out what x is, so we can put x in as 5.6. So that means you can use any of the sides you want. I'm going to use sine in this one. So the sine of alpha, so the sine of the angle, is always equal to the opposite over hypotenuse. So your opposite over hypotenuse here is 3.3 divided by 6.5. So alpha then is equal to the inverse sine, bring the sine across, of 3.3 divided by 6.5, and then you work out your alpha on the calculator. It gives you 30.51, but it asks you to work to the nearest degree, so that equals 31 degrees. So now that alpha is equal to 31 degrees, let's go back up here and see, fill it in on our diagram. So alpha is 31 degrees, that's okay, that's what we were looking for. The next question is asking you to find beta. So we're going to need this particular one. And you can see very clearly that alpha plus beta, these two things together, should give you 180 degrees. So on your workings down below, you don't have to do much except write in 180 degrees minus 31 degrees, and you get beta is equal to 149 degrees. That's the answer to that. So again, 149 degrees on this one. Beta 149 degrees. So look at the next question. Use the cosine rule to find the length of RS. So let's go back up, see if we can figure it out. So RS. So we are trying to go from here all the way to here. We're trying to find the length of that side. Okay, so what we'll probably do is just redraw out that triangle just so we can see it a little bit clearer. So basically we're dealing with a triangle that looks like this. We've got 5.6 on this side, we've got 8 on that one, I think we've got 149 on that. 149, 5.6 and 8. It is, okay, so let's work out our cosine rule. Again, remember, this is the side that we're going to be looking for. We're looking for that side there. So let's pop it in. A squared equals b squared plus c squared is equal to minus 2bc cosine of A. The important part is that angle there and this side here have got to be opposite each other when you're filling it in. So the angle that we have is 149, so the side opposite is x. So this is going to be x squared. So x squared is equal to the other two sides, which is 5.6 squared plus c squared, which is 8 squared, minus 2 times b, 5.6, by the c, which is 8, and that is the cosine of A, which in this case is 149 degrees. So now it's just a case of putting all those numbers in. Take your time with it, make sure you put it in correctly, and you should end up with x squared then is equal to 172.162 19014. X then is equal to the square root of all that. So x then at the end is going to give you 13.121. So to the nearest meter, that's going to be 13 meters. So x is 13 meters, or that long side is 13 meters. So up along here, we can write that in as 13 meters. So we've answered pretty much most of the parts already. That's 31. Okay. So SQT is a sector of a circle whose center is Q. Find the length of the arc TS and give your answers in meters correct to one decimal place. So what I'll do is I'm just going to draw a little diagram of this and I'll be back in 1 second. So in this one we've got our diagram drawn. This is taken straight out of our diagram up here. So we're looking at this particular shape here. So 8 and 8 and then the ST arc. So if we go back down here we can see that SQT is a sector of a circle whose center is Q. Find the length of the arc TS. So we want to find the length of this particular part. Now, of course, length whenever you're dealing with a circle or a sector of a circle is always circumference. So circumference of a full circle is 2 pi r, but we're not dealing with a full circle. We're only dealing with a certain amount of it. So how much of it are we actually dealing with? So we normally put the amount of degrees over 360. So what we need to really find out is how many degrees that is. For that, we go back up to our diagram. And what we can see here is from our diagram, we've got a lot of angles added in here. Let's get rid of some of this. What you can see is this is 31 degrees here for alpha. This one here is also going to be 31 degrees because opposite angles in that shape of an X will always be equal to each other. So the angle at Q would be the same as beta, which is 149. But we're only interested in the 31 degrees. We can bring that back down and use that in our calculations. So this is 31 degrees. So we've 31 degrees out of 360 multiplied by 2 pi r. And again, you fill in the numbers. So that's 2 multiplied by pi, multiplied by your radius, which is 8, multiplied by 31 over 360. And when you work that out, that's going to give you 4.3284. And correct it to one decimal place, that is 4.3, and your answer is in meters. The same thing then applies for find the area of the sector SQT. So now we want the area. This time, formula has changed. The area of a circle is pi r squared, but we're not dealing with a full circle. We're only dealing with 31 degrees out of 360 of it. So again, pop in your numbers. R squared is a squared multiplied by 31 divided by 360. And when you work that out, that's going to give you 17.3136. And rounded to the nearest decimal place is 17.3. That is meters squared because you're dealing with area. Okay, let's move on to the next part, which is going to be 2017.